Good morning, boys. Today we'll do the hydrogen chloride chapter. Now, as I told you, this is a part of inorganic chemistry. So, to learn this chapter, you need a lot of practice and writing. Okay, I'll discuss few important part of the chapter. We'll start with the preparation of hydrogen chloride gas. See, the first method is direct combination or synthesis. Now, this equation, if you see the hydrogen gas combining with chlorine in presence of diffuse sunlight. Now, you have studied this in class 8 hydrogen chapter, you remember? Hydrogen gas is reacting with chlorine gas in presence of diffuse sunlight to produce hydrogen chloride gas. Okay. Now, here moisture act as a catalyst, right? See the next method. From metallic chloride, reaction of metallic chloride with concentrated sulfuric acid also gives hydrogen chloride gas. Okay. When metallic chloride reacts with sulfuric acid and the temperature is below 200 degrees centigrade, it produces metallic bisulfate and hydrogen chloride gas. Now, when you are doing this type of equation, when you are writing this type of equation, you must balance it. If you do not balance the equation, then you will not get any marks. Now, next slide is on the preparation of hydrogen chloride gas by laboratory method from sodium chloride and concentrated sulfuric acid. Now, sodium chloride, when it reacts with concentrated sulfuric acid below 200 degrees centigrade, it produces sodium bisulfate and hydrogen chloride gas. Okay, temperature is very important in this case. It has to be below 200 degrees centigrade, and if you do not mention this temperature which is below 200 degrees centigrade, you won't get any marks for this equation. Now, sometime temperatures above 200 degree also gives hydrogen chloride gas. What is the reaction for this? Sodium chloride, exactly the same way they react with concentrated sulfuric acid above 200 degrees centigrade and they produce sodium sulfate and hydrogen chloride gas. But temperature above 200 degrees centigrade are not used because it's a wastage of fuel and the glass apparatus may break because of the high temperature. Okay, and also sodium sulfate, which forms a hard crust and it stick to the glass and which is very difficult to remove. So, for this reasons we do not use the second method for the preparation of hydrogen chloride gas. Okay. Now, what are the precautions we take for this? The precaution is the reaction mixture is initially heated very slowly. This is a precaution we take for the laboratory preparation of hydrogen chloride gas. Okay, and the lower end of the thistle funnel should dip below the acid in the flask. Otherwise, hydrogen chloride gas obtained will escape out from the thistle funnel. Okay, how do we collect this hydrogen chloride gas? Dry hydrogen chloride gas is collected by the upward displacement of air because it is heavier than air. Okay, and it is highly soluble in water, so it is not collected over water. The next slide is on the physical properties of hydrogen chloride gas, like color, odor and taste, then density, solubility, boiling point, freezing point, etc. Next very important part of this chapter is fountain experiment. Now, this experiment we carry to demonstrate the high HCl gas in water. That means hydrogen chloride gas is highly soluble in water. To demonstrate that, we demonstrate the high solubility, we do the fountain experiment. Now, what all things we need for this? We need dry round bottom flask which is filled with dry hydrogen chloride gas. Okay, and now that round bottom flask, mouth of that flask has a rubber stopper with two holes, one for the jet tube and one for the dropper which has water in it. Okay, now blue litmus solution is placed in a beaker. Okay. Now how to proceed? You can see that setup of the apparatus, how that setup. Now procedure is the dropper containing water is squeezed inside the flask. So what happens? It goes inside the round bottom flask. What observation we see? HCl gas present in the flask dissolve in water due to its high solubility. I told you that round bottom flask has HCl in it, dry HCl. So once you squeeze that dropper containing water inside the round bottom flask, that water dissolve the HCl. So what happens? They'll create a partial vacuum in the flask. Now, as we know that no place cannot be vacuum. So what happened? The outside pressure being higher, and it will push the jet tube, and they enter in that through the jet tube. They enter in the round bottom flask as a red fountain. Okay, so what is the interference for this experiment? That HCl is highly soluble in water and acidic in nature. Now this one is very important for 2021 ICC, so read it properly. In this slide, chemical properties of hydrogen chloride gas is given. It is a non-combustible and non-supporter of combustion. That means it does not burn or extinguishes a glowing splinter. Very important point. You can put double star next to it. Okay. Now what is the action of indicator? Action of indicator: moist litmus paper, which is original color blue, changes into red in presence of hydrogen chloride gas. Methyl orange, with originally is orange color, it turns into pink in presence of hydrogen chloride gas. Phenolphthalein, which is originally colorless, changes, it has no change, it remains colorless only. And phenolphthalein, which is pink, that means alkaline phenolphthalein, which is pink in color, original color, it is changes into colorless in presence of hydrogen chloride gas. Now let us see what happens when thermal dissociation of hydrogen chloride happens. Now hydrogen chloride dissociates when we heat the gas above 500 degrees centigrade to produce hydrogen gas and chlorine gas. Now this reaction is a reversible reaction. Now let us see few reactions of hydrogen chloride gas. First one is a jar containing hydrogen chloride gas. If we invert it in a full jar of ammonia gas, you can see a dense white fumes are formed. Now this fumes consist of the particles of solid ammonium chloride, which is suspended in the air. So what is the reaction? Ammonia, which is the gaseous, and reacts with hydrogen chloride, which is also in the gaseous state. They react and they form solid particles, ammonium chloride. Okay, next reaction is when hydrogen chloride gets reacts with metal like calcium, magnesium, zinc, they produce hydrogen gas and respective metallic chloride. Now this thing you have studied in the hydrogen chapter of class 8. Okay, what is that? This is a simple displacement reaction. What happens here? The metal, they react with hydrogen chloride gas and they produce the respective metallic chloride and hydrogen gas is released. See the equation here, like zinc plus HCl, it gives ZnCl and H2, which is released as a gas. Same with magnesium and iron also. Okay, so this much you write and learn. Next class we'll do the last part of the hydrogen chloride chapter.